These are the frequently asked questions for pre-calculus for section 2.8 day 2. I'm going to start with number 43. And this says that we should solve the inequality using a sign chart. And what that means is basically they don't want us to just get the graph of this and use that as a visual. So it says support graphically, which means, yeah, we can check our answer when we're done, but really we should be using the sign chart for this. So the first issue in number 43, the 2x minus 1 is perfectly fine. We've dealt with that before. We can certainly find that 0. But the square root of x plus 4, here's what we know. That has to be greater than or equal to 0. Absolutely has to be in the real number system. So we could square both sides. And then subtract 4. And we know that x has to be greater than or equal to negative 4. So what that tells us is, on our sign chart, to the left of negative 4, that's undefined. We're not going to bother trying to figure out whether or not we have positive or negative on that side. That has to be undefined. Now the other spot we need to check is when 2x minus 1 equals 0, which of course will be x equals 1/2. So now we actually have two places that we need to check the sign on, and that would be between negative 4 and 1/2, and then of course to the right of 1/2, so that we can answer the question, which is, when is this less than 0? So if we put a 0 into this function, 2 times 0 minus 1 is going to give us a negative 1. And then we'd have 0 plus 4 is 4, and the square root of that will of course be positive. So a negative and a positive, the result is going to be negative. And then with the 1/2, we would say, all right, let's try something bigger than that that's not too tough to work with. Let's try 1. If we put 2 times 1 minus 1 in, that's going to give us a positive. And if we put the square root of 1 plus 4 in, that's also a positive. So this will be positive. So the graph itself is going to be very similar to one we did in class. We'll be over here at 1/2, but back here at negative 4, like so. Now, what do we need to do? We need to answer the question. When is this less than 0? So when is it below? Well, that's where it's negative, right here. So between negative 4 and 1/2. And we don't want to include those two because those would actually give us 0. So negative 4 and positive 1/2 with our open brackets to indicate that we are not including those 2 points because they would be 0. And we do not have an equals bar on number 43. Number 49 is the next one on your list, and 49 is one of the problems that we had talked about in class where normally we would want to solve this by multiplying everything by the LCD, but our LCD for this would be the quantity x plus 1 times the quantity x minus 3. There's a negative in there, and we know that when you multiply both sides of an inequality by a negative, you have to flip the sign, so we're not sure how to deal with that. So what we'll just do is think of this as a hyperbola, and we will put these two fractions together by building them up to have the same denominator. And that means we really are still using the LCD. The LCD here is going to be an x plus 1 and an x minus 3. But we'll now have x minus 3 over x minus 3 times x plus 1 plus x plus 1 over x minus 3 times x plus 1. And we can now go ahead, because we have a common denominator, and add those two things together. So we have 2x minus 2, x plus x is 2x, negative 3 plus 1 is negative 2, and x minus 3 times x plus 1 is less than or equal to 0. And finally, we would go ahead and factor the numerator. Nothing's going to cancel, but that's okay because it makes finding those zeros easier as we go through there. So, 0, well, that's when x minus 1 equals 0. So, when x equals 1, we have a 0. Vertical asymptotes are when our denominator equals 0 because we'll be undefined. That's going to be at x equals 3 and x equals negative 1. And then we can make a sign chart so that we can answer the question about when this is less than or equal to 0. So we've got -1, +1, 3. First up, left side over here. Something to the left of -1, maybe -2. And I'm going to plug it in here and check for signs. If I put a -2 in here and subtract 1 and then multiply by 2, I'm going to have a negative result in my numerator. If I put a -2 minus 3, I will have a negative result. And if I put -2 plus 1, I will have a negative result. 3 negatives, that is an odd number of negatives. That is going to give us a negative result. Between -1 and 1, our favorite number, 0. Put a 0 in here, we're going to get a -2 on the top, so that's going to be negative. A 0 down here will be negative, and a 0 here will be positive. That will give us a result that is positive because we have an even number of negatives. From 1 to 3, put a 2 in here. If we put a 2 in our numerator, this time we're going to get a positive response out of that. If we put a 2 in x minus 3, we're going to get a negative response. And if we put a 2 into x plus 1, we're going to get a positive response. So that's negative. And you can see how the sign is changing here with each of these intervals. But we have one more to go. Let's try to the right of 3, maybe a 4. 4 minus 1 times 2, definitely going to be positive. 4 minus 3, that's going to be positive. And 4 plus 1, that will be positive. So we do have sign changes throughout. And this was for problem number 49. Now, finish it up. We want to know, when is this less than or equal to 0? Well, here's the less than. There's our negatives right there. And the numbers that we see as our cutoffs, those were zeros or vertical asymptotes. So what we have to do is remember, we can't include vertical asymptotes, but we can include zeros. And this is one of the reasons that in the past, FAQs I've said, sometimes I'll put a dot on the ones that definitely are the zeros so that you don't mistake those for vertical asymptotes. So this will end up having our negatives from negative infinity to that -1 asymptote, but not including that. And then from our 1, which will be included because that is a 0 and we did have an equals bar, to 3, which was one of our vertical asymptotes. So we do not include that. So those are the two that we would use for number 49. Number 58. The Grosvenor Candy Company finds that the cost of making a certain candy bar is 13 cents per bar. Fixed costs amount to $2,000 per week. If each bar sells for 35 cents, find the minimum number of candy bars that will earn the company a profit. Well, profit comes from revenue minus costs. So the first thing I would do is reread up there and find out how are they making money. Well, they're selling those candy bars for 35 cents each. So I'm just going to use an X for how many I have of those. The cost of the candy bar is 13 cents each, plus that fixed cost, and again, that might be for lease, heat, light, all of that good stuff that you have those fixed costs for. So if we want to find the profit, we need the revenue, 0.35x, minus all of these costs. And then profit means we want to make money, not break even. So we want that amount to be greater than 0. Even if it's a penny, we've made a profit. Now, most of the time where the mistake is made here is the fact that we have to distribute this negative because we are truly subtracting those costs. And then we just go ahead and do a little math. 0.35x minus 0.13x is 0.22x. And add the 2,000 to both sides. There's no flipping the sign when you add or subtract. And then we would divide by the 0.22. And x will be greater than 90, 90.909, blah, blah, blah. But what we care about here is this was candy bars. So we do need to say it's going to have to be 9,091 candy bars to make a profit. We have to round up. Because if we round down, we won't quite break even. And they definitely wanted to make a profit here.